Welcome, Line Sciences, to another lesson for today. Today we're going to concentrate on molecules of life. Now, some of you have no idea what it is, and I'm going to tell you it's a really, really important section. If you were going to build a building, this would be the foundation. So a lot of the work that you are going to do after this, you're going to have to keep your notes and keep going back and remember all the little sections that we are going to do when it comes to molecules of life or biochemistry, what makes us live. Okay, now I want to pose a question for you. Have you ever thought about why you need to eat food and why you need to drink water? And lots of you say, no, I need it because I need energy, because I need to live. But what it boils down to very, very simply is you are made up of something. And I want to show you this diagram. Okay, the concept map that we're going to look at, I'm going to just show you over here. Right, when we look at molecules of life, you're going to look a lot about terminology. You're going to hear things that you might not necessarily know the words for, right? But I want you, when you're thinking of molecules of life, I want you to break it down as, why do I need to eat these foods? Why do I need to build my body, to make my body work very, very well? Now, the concepts that we're going to look at today, if we look at the concept map, we're going to learn, all right, the terminology about inorganic molecules, all right, and organic molecules. Now, they are different. They have very similar differences. And believe it or not, you eat these every single day. You eat food or you drink water, and you are taking these into your body all of the time. But you just never know the science behind it, the chemistry behind it. Why am I going to eat it? Okay, now if I have a look at this today, if I say words like water, oh, there's my pen. We go to the pen over here. Let's use a different color. If I say water and I say minerals, and when I say minerals, I say calcium, I say sodium, I say potassium. Maybe some of you take little vitamins or minerals, those kind of things. Those are the things that we're going to talk about today. All right, now where do they fit into things? I've got a list here of keywords that are on the board, but I'm not going to go through each as we go along. You'll see I'm going to mention the definition when we get to each of the sections. So if you want to go back or you check in the notes, just make sure that you go through the list, all right, and that you then understand each of the terms that we are going to give. So I'm not going to go through each one now because they might not make sense to you at this particular time. Okay, so what are we looking for? Okay, guys, so if we have a look at the picture at the top over here, this is a cell. And some of you might have heard of what a cell is, some of you not, all right? So I've just given you a diagram of what a cell is. Now, what a cell is, you're going to probably do it in the next segment. A cell, all living things are made up of cells. So if it was to build a house, they would be the brick, right? So we just have a brick, unicellular, all right, unicellular, only one cell, all right, or multicellular. Well, don't worry about the terminology here, multicellular, all right. Now, what that means is when I build something, I need things to build, right? So the food that I eat is ultimately going to build that cell. And if the cell makes up my body, all right, the food that I eat builds me properly and also makes sure that I function properly, all right? I want it to look good and I want it to do good, right? It must be able to do things properly and it must be able to look, all right, it must do the right things. Okay, so guys, when we look at these molecules, that's exactly what we're looking at. We're looking at the food that I eat, what am I going to use it for? Okay, now, two concepts that we're going to look at. Today's lesson, we're going to look at the concept of inorganic molecules. Those are molecules, all right, that we usually say are are non-living. They're really small, they're very, very simple, they're called it non-living, right? And it's those kind of things that we usually use the term nutrients or minerals. Okay, the next ones after this, we're going to look at what an organic compound is, but today we're just going to look at what an inorganic compound is. All right. Now, if you have a look at the board, an inorganic compound, already you should have a look, right, is water, and it's going to be minerals. And as I said to you, water and minerals, small things, small elements, not big compounds, simple things that our body needs almost on a continuous basis for us to build and to function properly. Okay, so guys, the organic compounds that we're going to look at later, they are much bigger, they are made up of so many more things, and a lot of you will recognize when I say proteins, carbohydrates, lipids or fats, vitamins, right, or your DNA and your RNA. So today we're just going to concentrate, all right, on the inorganic molecule. Now, the most important, and I keep saying important, inorganic molecule in your body is this, water. Water. Water makes up almost 64% of the volume in your body, all right? And why is it most important? Because nearly everything needs to happen in a watery medium. Okay, so what do I mean by that? Now, I want you to think about things. I'm going to put a list up on the board here, right? And I want you to think. I'm not going to go in the order, all right? I'm going to just go in different orders. Now, I want you to think about something, all right? Lots of you don't like water, plain water, right? Maybe you like Oros, or maybe lots of you like Coca-Cola, or those kind of things, all right? What are they? They're something dissolved in water. I don't think you would really like it if you were drinking water and all these clumps and lumps and hard things were in it all the time. You want it to be nice and smooth. You want all your Oros to dissolve, and you want to drink it nicely. And it's exactly the same as your body, all right? What do you want? You want to take something in, and you want it to dissolve in there so that your body can keep it and you can hold it. Right, so if we have water, we make up most of our body is water, we can store a lot of that stuff, right? Lots of small stuff dissolved in there. Okay, next thing I want you to understand, think about transport. Transport, blood. So I'm sure some of you have cut yourself before. What happens if the blood, it runs out, doesn't it? That shows me that it's a liquid, it's water. Now, if my blood wasn't water, right, it wouldn't be able to travel through my body. It wouldn't be able to transport. Things will get stuck, and if things get stuck, then what could happen? I could get a blood clot, I could get sick, maybe I could even die. All right, so transport, where I want water, what am I going to get it? Okay, supporting cells. Now, lots of you, I want you to think of a plant, all right? Now, if you cut open a plant, you're not going to find a skeleton. You're not going to find bones. So how does a plant stay upright? Water. So if I fill a cell with water, this concept of a cell, if I fill it up, imagine taking a water balloon, all right? You take a balloon, you fill it with water, and what does the balloon do? It expands, all right? And it keeps its shape. Exactly the same with plants. Plants need water to keep those cells, all right, we call the word turgid, we'll look at it later, and to keep them nice and big, and obviously to be able to, all right, get those plants to stay upright. Okay, excretion, right, what I'm doing a lot of at the moment, I'm sweating, all right? So when you sweat, you want to get rid of it in the water form. Why? Why water? Because when it's in water form, that hot air evaporates and it cools me down. I want you to think when you go to the toilet, all right? When you get to the toilet and you know you desperately need to wee, right? What do? You're going to, the wee's going to come out, urine, as water, right? It's easy to flush my body. It's easy to get the waste away. Water is much more easy, or an easier way of getting rid of things. Okay, then the last thing, a chemical reaction. All right, now what do we mean by that is chemical reactions are how my body works. So say, for example, I take a bite of bread and I start chewing that bread. What's in my mouth? It's water, it's saliva. But what's in that saliva? It's little enzymes that start to break down the bread, right? All things in my body, when I need things to move, when I need muscles to do their work, right? Where's that reaction going to come? Water. So if I cut you up, you're not biltong, right? Everything is nice and moist. There's water, there's fluid everywhere to ensure that your body is going to work at tip-top, right, condition. Okay, guys, we're going to take a quick little break. Go and have a little break, stretch your legs, and we'll be right back.